Alright, so here's my seventh example on inverse Laplace transforms. We have the inverse Laplace transform of 1 over s squared plus 1 times s squared plus 4. And if you look through the table here, you're not going to find something that looks like that. So we're going to have to rewrite it. We're going to have to use partial fraction decomposition. And you can see this is already factored. So I have 1 over s squared plus 1 times s squared plus 4 is equal to, now hopefully you remember how to do this, that's as plus b over s squared plus 1 plus cs plus d over s squared plus 4. And now I need to multiply everything by the common denominator. And so that's going to leave me with 1 equals as plus b times s squared plus 4 plus cs plus d times s squared plus 1. Alright, so in this one, I can't do like I did in example 6, where I let s equal something and zero this out, because this is never going to be negative 4, and over here s squared is never going to be negative 1. So what we have to do is FOIL this out, and hopefully you remember how to do that. So when I FOIL this out, I get 1 equals as cubed plus 4as plus bs squared plus 4b plus cs cubed plus cs plus ds squared plus d. Alright, so what we're going to do here is we're going to group like terms together. So this is 1 equals as cubed plus cs cubed. Okay, so those are taken care of. And then I have plus bs squared plus ds squared. So that takes care of that. And then I have plus 4as plus cs. So that takes care of that. And then I have plus 4b plus d. Okay. And then here I have 1 equals, and then I'm going to factor out a s cubed. And so I have a plus c times s cubed plus b plus d times s squared plus 4a plus c times s plus, and then 4b plus d. Alright, and then if you look here, you see the 4b plus d. This term here is my constant term. Okay. It's my constant term. So 4b plus d has to equal 1, my constant term over here. And so I know 4b plus d has to equal 1. And then let's look at this one, 4a plus c times s. Well, there's no s over here with a coefficient in front of it. So 4a plus c would be 0. And then I don't have an s squared. So b plus d would have to equal 0. And then there's no s cubed. So a plus c has to equal 0. Alright, so now I need to solve for A, B, C, and D. Alright, well, here I have C is equal to negative A, and I have D is equal to negative B. Alright, so look at this D here. I can replace it with negative B. So 4B minus B is equal to 1. So 3B equals 1. B is 1/3. And then here you see the 4A plus C. Well, C is negative A. So I have 4A minus A equals 0. And so that gives me 3A equals 0. So A is equal to 0. Alright, and then D is equal to negative B. So D is equal to, well, B is 1/3, so that's going to be negative 1/3. And C is equal to negative A. Well, A is 0, so C is 0. Alright, so now I have B and I have D. Well, A and C is just 0. So I'm going to plug those back into this. Well, since A and C are 0, these are going to go out. And so I'd be plugging in B and D. Alright. And of course, you know, down here, B is 1/3, D is negative 1/3. So let's plug those in. Alright, so first thing I'm going to do, I'm going to rewrite my Laplace transform, my inverse Laplace transform. I'll rewrite this. Okay. And so I have the inverse Laplace transform of 1 over s squared plus 1 times s squared plus 4 is equal to, alright, so I'm going to put 1/3 in for B. So that's going to give me 1/3 over s squared plus 1, and then I'm going to put in the minus 1/3 for D. So that's going to be, this would be minus 1/3 s squared plus 4. Alright, so this is going to be inverse Laplace transform of 1/3 over s squared plus 1, and then minus the 1/3 over s squared plus 4. Alright, so now let's see what we have now. Let's look at our table again. I got s squared plus 1 and s squared plus 4 in the denominator. Alright, so you can see here s squared plus a squared. Okay, so this is going to be this one, number 7. But notice I need a in the numerator. Okay, see I have a over s squared plus a squared. Alright, so this is going to give me, now see I need the a. In this case, a is 1, because I can rewrite 1 as 1 squared. So I need a 1 up here, so I'm going to bring out the 1/3. Alright, so that's going to give me, let me go back to the change colors here. So that's going to give me 1/3 inverse Laplace transform of s squared plus 1 squared. So I need a 1 up here, and that's when you factor out the 1/3, that leaves you with a 1, minus, now here a is 2, so I need a 2 in this numerator, so I'm going to bring out this 1/3, and I have the inverse Laplace transform, and I've got s squared plus 2 squared. So I need a 2 up here, so since I multiplied by 2, I need to come out here and multiply by 1/2. Alright, so this is equal to 1/3, and the inverse Laplace transform of this is sine of AT, and in this case A is 1, so that would just be sine t. So that would be sine t minus, and then I have 1/6, and remember this is what, sine AT. Well, in this case A, see my A, that's 2, so that's going to be sine of 2t, and this would be my answer. Alright, so I hope this video's helped. If you like them, you can check out my other videos, and you can subscribe. Alright, thanks.